So in this problem, we're looking at an airplane flying in a certain direction with a speed and there's a wind. But the first thing we want to do is look at the notation that is shown here, the n 30 degrees east, and make sure that we're clear on what that means. So when we see this notation, what that's saying is we're heading in the north direction, but not due north. We're going to go 30 degrees to the east, and that's the direction that we're heading. The wind also has a certain direction. We're told that the wind is also heading north, however it is heading also 20 degrees to the west. So what we want to do is combine those two pieces of information together, the direction that the plane is going and then the direction the wind is pushing. We're going to do that in a diagram below. So first thing, I want to put north on my diagram, and I know that the plane is looking to head this direction, and it's going at 600 miles per hour. And I know that the wind is going to push back at about 30 miles per hour in this direction. And if you want to include a little north there, you can. Which means that the plane in all will be heading in the green direction shown here. So we have the wind at 30 miles per hour and the plane going at 600 miles per hour. Now our goal is to figure out how long is the green vector and what is the angle at which it's heading. So to do this, we want to look at this triangle that we've drawn with blue, orange, and green. It looks something like this. It has sides that are 600, 30, and we can find out a little more about some of our other angles. To do this, we want to use the angles that we were given. We were told that this angle here is 30 degrees. We were told that the angle here was 20 degrees. Continuing this dotted north line, I know that this angle here must be congruent to the 30-degree angle hit here, which means that the angle inside the triangle will be 100 minus 20 minus 30, or 130. Once we know this information, we have enough to find out the long length of the triangle using law of cosines. So if we call this side length x, I know that x squared is equal to 30 squared plus 600 squared minus 2 times 30 times 600 times cosine of 130 degrees. Which means that x will be equal to, grab your calculator, move to the side so we can see our equation, the square root of 30 squared plus 600 squared minus 2 times 30 times 600 times cosine of 130. Be sure that you're in degree mode. And we should get about a 619.71. And that is the speed at which the plane is moving. And looking at our picture, we can see that that makes sense. The plane should be moving faster with the wind than without the wind. Now the last piece of information we need to find out is what is the angle that the plane is moving at. And it could be a little bit confusing to decide which angle it is that we're looking for. So if we look back at the original diagram, the angle we want is this angle that I've shown with the yellow highlighter, because we want to again put it into that notation of north something east. You can see that it is east of north. To do that, we're going to need to find out what this angle in the triangle is that I've highlighted in blue. And then we can see that same angle here in the other triangle diagram. To find an angle, we have a few choices. We can use law of sines, we can use law of cosines. I'm going to use law of sines for this problem. I know that the angle I want, if I call it alpha, that sine of alpha over 30 should be equal to sine of 130 degrees over the side that we just found, 619.71. Which means that sine of alpha will be equal to 30 times sine of 130 degrees over 619.71, which means that alpha, if we go to our calculator, should be equal to sine inverse of 30 times sine of 130 divided by 619.71, or better yet, instead of typing in an approximation, we can pull our answer from the previous problem. And we get that our angle is about 2.13 degrees. That's our blue angle, which means that our final angle will be 30 minus 2.13 degrees. And you get 27.87. And our final answer, therefore, will be that we are going 619.71 miles per hour at north 27.87 degrees east.